A glowing shape that looks like a question mark has accidentally shown up in a new picture taken by NASA's James Webb Space Telescope. Scientists have some ideas about what this might actually be. The original near-infrared image was released on July 26 and depicted Hairbig Haro 4647, which is a complex of Hairbig Haro objects located 1,470 light-years away, in the Vela constellation within our Milky Way galaxy. Hairbig Haro objects, shortened as HH objects, are some of the rarer sights in the night sky, taking the form of thin spindly jets of matter floating amongst the surrounding gas and stars. They are a byproduct of the star formation process. Within a large dense cloud, matters collapse due to gravity, and most of the material collects in the center of the cloud, forming a protostar. Protostars continue to ingest the gas and dust that immediately surrounds them in a disk. When the stars eat too much material in too short a time, they respond by sending out two-sided jets along the opposite axis, settling down the star's spin and removing mass from the area. When these jets collide with the interstellar medium, they give rise to the small patches of bright emission which form HH objects. Although HH objects are visible wavelength phenomena, many remain invisible at these wavelengths due to dust and gas, and can only be detected at infrared wavelengths. HH 4647 was discovered in 1977 by American astronomer R.D. Schwartz. HH 46 is the nebula on lower left, while HH 47 is in the upper right. It is relatively young, only a few thousand years old, and it is one of the most studied HH objects due to its brightness and collimated jet. However, the remarkably sensitive Webb telescope has provided the clearest and most intricate image so far. Unlike other space telescopes, Webb can observe the cosmos using longer wavelengths of light. The two-sided orange lobes were created by earlier ejections from these stars. The star's more recent ejections appear as blue thread-like features, running along the angle diffraction spike that covers the orange lobes. The delicate semi-transparent blue cloud is a region of dense dust and gas, known as a nebula. Webb's crisp near-infrared image lets us see through its gauzy layers, showing off a lot more of HH 4647, while also revealing a wide range of stars and galaxies that lie far beyond it. The nebula's edges transform into a soft orange outline, like a backward L, along the right and bottom of the image. The blue nebula influences the shapes of the orange jets shot out by the central stars. As ejected material rams into the nebula on the lower left, it takes on wider shapes, because there is more opportunity for the jets to interact with molecules within the nebula. Its material also causes the star's ejections to light up. Over millions of years, the stars in HH 4647 will form fully, clearing the scene. However, the appearance of this mysterious object in the background of this image steals the thunder. This cosmic question mark hasn't undergone thorough observation or study, so scientists aren't exactly sure about where it comes from and what it's made of, but they do have a few ideas based on its shape and location. The very first thing you can rule out is that it's a star in the Milky Way, said Matt Kaplan, assistant professor of physics at Illinois State University. Because stars always have these really big spikes. Blue objects with diffraction spikes in this image are stars, and the closer they are, the larger they appear. It could be a merger of two galaxies that are at probably billions of light years away, and are much farther away than Hairbig Haro 4647, said Christopher Britt, education and outreach scientist in the Office of Public Outreach at the Space Telescope Science Institute, which manages the Webb telescope's science operations. White and pink spiral galaxies are shown like this, and they are significantly farther away than stars in the image. The tiniest red dots in the image are often the oldest, most distant galaxies. Galaxy collisions are relatively common on cosmic timescales, especially considering the vast number of galaxies in the universe. However, these collisions occur over millions to billions of years, making them less frequent on human timescales. Galaxies are spread out across the universe, and their mutual gravitational forces can cause them to interact and even collide. These interactions can lead to various outcomes, such as the exchange of material, the distortion of shapes, and in some cases full-scale mergers. In fact, the Andromeda Galaxy is approaching our Milky Way at nearly 250,000 miles per hour. In 4.5 billion years, it will collide with the Milky Way. If you haven't already, be sure to check out our video on this titanic collision. Link is in the video description. That concludes this video. Don't miss out on our next installment as we continue to unravel the secrets of the cosmos. We hope you enjoyed the video. Be sure to hit that like button and subscribe to our channel. See you in the next video.